Now we're going to discharge the water closet, and you'll see trap movement, and you'll see that the shock wave actually will blow this piece of plastic right off. Remember the toilets that by the way, that was an extreme example, but one that we still could resolve. All right. Now you're going to see a naked papa. Please avert your eyes if you're offended by nudity. So here it is in its splendid glory, and as you can see, the discharge has primed it. You have a little bit of trap movement. It attenuates the shock wave, releases it harmlessly back into the system. Now, one of the amazing things about this is that people ask me, said, well, can I use this without air admittance valves? Absolutely you can. This can be added back into a system to ensure and help protect the trap seal of a building. So this can be installed as an addition to a traditional system. The studies that have been done show that this actually exceeds traditional systems with air admittance valves. So I would submit to you that the air admittance valve coupled with the papa is the better way. That being said, can you install this on a traditional system? Absolutely. Now, keep in mind, though, that you can make a traditional system perform equally as well as this, but you're going to have to make the relief vent full size as the waste stack. The yoke vents will have to tie in every so often, and the return vent from the branch will have to be full bore also. So as you can see, that could be quite costly and prohibitive in expense by utilizing that type of application.
You may have said earlier, what was how many stories were in that building that we saw the video where the toilet was being?
42 stories.
42 stories.
42 stories. And we were able to resolve that with 4 at the base of the stack. Now, we have to keep in mind, in all fairness and disclosure, that that system was actually dumping into a dry well that waited for discharge as it built up to a certain level.
Okay.
So that was helping, facilitate
that type of phenomenon. Yeah.
That type of.
Otherwise, you'd have that in every.
That's right. Yeah. Right. So, but that was an extreme case, and if it will function in an extreme case like that, then you could rest assured that in different applications, that if you have an issue, that this is a problem solver also. And we have solved problems in the United States. We already have 12 jobs in the United States that have been installed utilizing this. We have the Hyatt Hotel in Denver, Colorado, 32 story. That was the first building that we did. And we did the washer machine lines and the kitchen sink lines in that building because the city of Denver would not permit Sovent to be installed on those applications. And since that worked so well, we've now done 10 other buildings there. We're just starting the Spire, which is a 48-story building, which will have 400 papas and over 2,000 air admittance valves in. We just finished up One Lincoln Place, which is a 32-story building, utilizing a full-blown papa system and air admittance valves. Plus, in Royal Oaks, Michigan, we have a 10-story condo that's been in place 3 years now, and there has not been a single issue. It works so well that in Ann Arbor, we just finished up another project for those folks. They were so pleased with it.
What, are there standards developed for this?
That's a good question, and the answer is the standard will be ASSE 1030, and we should have that ready to present by the end of the year. It's already been out to the working group. The working group has already responded, and so that will be the standard. And this will be part of an engineered system. So this is what we are presenting to the engineers, and that's the way that it's been installed currently, is that it's been installed as part of an engineered system. It's being installed worldwide, even in Dubai. That world's tallest building now will be utilizing this system in their high-rise buildings, because they have discovered, when you get above, 50 floors, that there are a lot of times issues that must be resolved. Think about this: the Empire State Building, which utilizes a dual system, had tremendous venting problems, and they spent years trying to get that resolved, and they finally did by running relief vents out every so often. And that was something that nobody really kind of talks about. Once you get above 50 floors, there are transients that occur that are promulgated by these changes in directions, and that people have really not understood what has happened until Swaffield has done his research. And that's not so much that people were wrong, but the availability of computers and able to recognize and view and see these things occurring have been our limitations. Now that we have the technology to explore these issues, we are coming up with techniques and technologies like the PAPA to present to the community to help further safeguard the health and welfare of our constituencies and our environment.
Question: on a single stack system, how does it perform in a comparable drainage in terms of quantity?
When you say a single stack system,
A
a solvent, well, you have to remember, a solvent system is designed so that it takes the water and slows it down from terminal velocity at every floor. The limitations with that is that you have these big, bulky devices at every floor that are problematic. And that you have to remember that the branches and the venting comes from the fact that you must ensure that the design allows for a maximum of 75% reserve for air, and at 100% capacity, no more than 5% flow of fluid in the branch to allow for venting. So if you vary from that system, you may have a problem with your design criteria. The solvent system is a good system, it works, but again, it doesn't allow you the flexibility that the Studor and PAPA system give you, because you still have a single stack. You're terminating the branches to air admittance valves, which allows you to go wherever you want to. The pop-up can be installed either vertically or horizontally, and up to 10 feet away from the stack, so that that gives you a great deal of flexibility to install this system and enable you to be very competitive. In fact, we would say that it would be less expensive than the solvent system.